So percentages are a special kind of ratio. And we're used to the percentage symbol. And if you look at that symbol close, you just see a couple of things. You just see a slash, which means divide, and you should see 2 zeros, which means 100. Percent means divide by 100. And it's a shorthand that was developed a couple hundred years ago, and people just found they divided by 100 so much, it's nice to have a shortcut symbol for it. So when I see something like 50%, again, per means divide, and cent means 100, and the symbol literally shows me that I ought to divide by a 1 with 2 zeros. So that literally equals 50 divided by 100. Now from there, we could turn that into a decimal, or we could reduce the fraction. So we have two options right there. We could do the decimal version, which often we'll use a calculator, but we don't have to, or we could do the fraction version. So if I go for the decimal version of that, 50 hundredths, I might write it like that. 5, 0, the zero's in the hundredths position, so that's 51 hundredths. Now we know that trailing 0 is irrelevant, so we could also call this 5 tenths. As a fraction, we would reduce, and if I reduce 50 over 100, I might take that 50 over 100 and say, hey, I could divide top and bottom by 10 and get 5 tenths, and then realize, well, I can still divide this time by 5. So I could also call this 1/2. So 50% literally means take 50 and divide by 100. We can represent that as a decimal by carrying out that division by 100, or we can reduce it to be a fraction. Percent. Divide by 100. Now, in terms of modeling that, there's a couple ways we do that. So we can use a linear model or an area model. So I got linear model versus an area model. With a linear model, what we do is we draw a rectangle, and I'm going to make my rectangle, since I have a grid here, 10 units long. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want to end my rectangle right there. And then usually I'll make some notes, like at the beginning is 0, at the end is 100%. Now, a percent isn't a regular number because that symbol on the end means divide by 100. And if you take 100%, which really means 100 divided by 100, right? Because the percent symbol means divide by 100, you get 1. So what is 100% as a number? It's just 1. And often with the linear model, we'll have two scales. We'll have the percent scale on one side, and we'll have just the regular number scale on the other side. And so a moment ago, I had the number 50%. So if I wanted to show that on a linear scale, I would go find 10, 20, 30, 40. That right there would be my 50%, which I could also represent as 0.5 or 1/2. So the linear model is just either a line segment, often it's just a thin rectangle, where we compare the percent version of a number versus the regular number version. And we always want to look at the percent versus the regular number, 50% versus 100%. And we always want to see, where does 100% live on that linear model? So we'll look at some other versions of that. The area model for a percentage typically uses a 10 by 10 grid to demonstrate what a percentage means. So let's build one. So we'll start here and go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and same thing down. All right, pretty sure I counted correctly there. We'll find out in a moment. So then I complete that 10 by 10 grid. So this grid right here, since 10 by 10 equals 100, then I can show any kind of percentage related to 100%. So I have 100 squares in this 10 by 10 grid. So I can show what 50% looks like in a lot of different ways. Easiest way would be to just split this in half one way or the other. Maybe I'll split it in half vertically here. And then select part of this. How about this part right here? So this part could be the 50% that I want. Right there. So we have a couple of options in playing with percentage, and sometimes one has an advantage over the other. Sometimes they both work. Now, a percentage does not have to be less than 1. It could be greater than 1. So let's take a look at that. How about something like 120%? So we'll take a look at that in a linear model, and we'll look at that in the area model. If I'm going to use the linear model for this, then I need to know what 100% looks like. So I need to come out. I think that's about right there. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 100% right there. And I designed this so that each of these squares here is 10%. So that would be 10% right there. That's 0. This one right here is 100%. And if I want to see 120%, I need to go out farther. So another 10, 20. So if I extend this out a little here, then this endpoint here is my 120%. And then with the linear model, we usually show what it looks like as a regular number. So for example, down below here, 0 is 0. 10% is 10 out of 100, which reduces to 1/10. So that would be 0.1 right here. 100% is 1 as a number, and 120% would be 1.2. Let's double check that. 120%, percent literally means take your 120 and divide it by 100. Shortcut for dividing by 100 is to shift the decimal point 2 places, so I get 1.20, which can be more easily written, neatly written as 1.2 or 1 2/10, if I avoid slang there. So linear model for 120%. Let's do the area model. If we're going to do the area model, we have to show what 100% looks like as a 10 by 10 grid. So here's 10 that way. That should be 10 that way. So here is my 100%. Okay. 10 by 10. If I want to show 120%, that means I need to come another 10 over. So I'm just going to extend this out to the right here. So 10, 30, 40, 50. That right there should be another 10. Good, got it. To draw 120%, we have a lot of options. We know that the first square is 100. So then if we go over 1/10 and then 2/10, that right there should be 120, right? Think about the picture above. So in this case, let's pick a different color and draw a line here and then shade the 120%. So here is my 120% using the area model. So percentages can be more than 1, more than 100%. They could be less than 100%. Percentages can also be fractions of 1%. Let's think about that for a moment. Fractional percentages. That is less than 1%. So I'm going to draw another grid in here for 100%. And I lost track there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, good job. So here's my 10 by 10 grid. So for example, I want to know, what does 0.5% look like? Well, 1% would be one of these squares because this is a 10 by 10 grid. 1%, remember, is 1 out of 100. 0.5% should be half of one of those. So I'm just going to come down maybe to this bottom one here. I'm going to cut it in half diagonally. Let's use red actually. And so just that bottom of the diagonal, that right there would be 1/2 of 1%. Now, think about this for a moment. 1% is 1 out of 100. It is 1/100th. So 0.5% has to be less than that right there. So what is 0.5%? Well, we have to take 1/2 and divide by 100. When we divide with fractions, we multiply by the reciprocal of the second one. So that would be 1/2 times 1 over 100, which gives me 1 out of 200. And let's see if that makes sense here. As far as squares go, there are 100 squares in here. Now, if I cut each of those squares in half with a diagonal, then that means for every square, I get 2 triangles. 2 times 100 is 200. So one of those triangles is 1 out of 200 in this percent grid here. So 0.5% is 1/200th. Now let's play with this a little more. 1/2 is the same as 0.5. So 1/2% is really the same as 0.5%. Percent means divide by 100. So this is 0.5 divided by 100. And when you divide by 100, you make the number smaller by moving the decimal point twice to the left. So this would be 0.005, right? Let's think about that. The decimal used to be right here, and I had to move it 1, 2 places to divide by 100. So 1/200th is the same as tenths, hundredths, thousandths, 5 thousandths. How many times is 5 going to 1,000? 200 times. So there are fractional percentages. And so if somebody asks me, what is 1/2% as a decimal, or what is 0.5% as a decimal, I would say 0.5% as a decimal is 0.005, right? On this side, I have percent notation. On this side, I have decimal notation, or just regular number. And I could write that number as a decimal here, or as a fraction. And again, we just discovered as a fraction, it's 1/200th, hundredths reduced. So that's basics about what a percent is and how we model them. Next, we need to play about using them in different contexts.